So very warm welcome once again. So in my present video, I am going to cover about how to find the state of hybridization of carbon in various molecules, and also how to find total number of sigma and pi bonds in a molecule. So in my earlier video, I have explained all about the sigma and the pi bonds. So now I will start with the few examples. So these examples you must have read earlier also. So I have taken these examples: methane, ethene and ethine. So these are very simple organic compounds. So I will explain one by one. This is methane, CH4. So it is written like this: C, and with C, 4 hydrogen atoms are attached by the single bond. So in all such cases where carbon is having, as a central atom, where carbon is having all the 4 single bonds, So first point, all these single bonds are the sigma bonds. So all these 4 single bonds are the sigma bonds. So in methane, it is having 4 sigma bonds and no pi bonds. There is no pi bond here. And this carbon is having this sp3 hybridization. So where carbon in the molecules where carbon is having only single bonds, so then the hybridization state of carbon is sp3, and the shape for this molecule will be tetrahedra. Okay, so once again I will repeat. So in this methane, because all the single bonds are there, so all these single bonds, all these CH single bonds will be sigma bonds, and all such carbons which are having only the single bond, for that type of carbon, it is in the sp3 hybridized state and the shape is tetrahedra. So now the next example is of ethene, and we know it is C2H4. So we can write it like this: 2 carbons are there, both of them are having 2 hydrogen atoms which are attached to the carbon by the single bond. So these 1, 2, 3, 4 by the single bond, and between these 2 carbon atoms double bond is there. And whenever this double bond is there, one bond will be the sigma bond. This one will be the sigma bond and the another will be the pi bond. So first we can see how many sigma bonds are there in this ethene. So I have written sigma CH. So this sigma CH bond, this is the 1, 2, 3, 4. So sigma CH, there are 4 bonds. Sigma CC, sigma bond between the 2 carbon atom, we can see only 1 sigma bond is there. So this is 1. So total in this ethene molecule, total sigma bonds will be 5 sigma bonds. It will have 5 sigma bonds, 4 plus 1. And how many pi bonds? Only this 1 pi bond is there. Okay, so then because all such molecules where carbon is having 1 double bond, the hybridization state of such carbon is sp2. Always we should remember. So both these carbons are having double bond, 1 double bond, so they are sp2 hybridized. And in such cases, the structure of the molecule, shape of the molecule will be trigonal planar. Trigonal planar, and the angle between these two bonds will be 120 degree. Okay. So once again I will repeat. So ethene molecule, we can write it like this, C double bond C, and all the 4 hydrogen are attached to the carbon by the single bond. So first we can count the sigma bond between C carbon atom and the hydrogen atom. So it is 1, 2, 3, 4. And then sigma bond between the 2 carbon atom, it is only 1. So total number of sigma bonds is 5 and pi bond is only 1. And in such cases where double bond is there with carbon, it is in sp2 hybridized state and the shape is trigonal planar. Now coming to the next molecule, ethine. It is C2H2. We can write it like this, CCHH. So between both these carbon atoms, we know carbon is tetravalent. So to complete the valency of carbon atom, there will be a triple bond between these 2 carbon atoms. So we can see this CH will be the sigma bond, same here CH sigma bond. And in this triple bond, the central middle one between the 2 carbon atom, this will be the sigma bond. And this bond above and below, both these will be the pi bonds. Okay. So again here we can write the number of sigma bonds between C and H. This is the one sigma bond between carbon and hydrogen. This is the another. This is 2 plus sigma bond between the 2 carbon atoms is 1 because this one is only sigma, so 1. So total number of sigma bonds here are 2 plus 1, 3 sigma bonds. And how many pi bonds? This one above and 1 below. So 2 pi bonds are there. And all such cases where carbon is having 1 triple bond, the hybridized state of carbon is sp. So here both these carbons are in sp hybridized state and the shape of this molecule will be linear and this angle is 180 degree. So once again I will repeat. So first we can write this ethine molecule like this. There is a triple bond between these 2 carbon atoms. This attached to hydrogen, single bond. This attached to hydrogen by a single bond. So sigma bond between carbon and hydrogen 1, 2. Sigma bond between 2 carbon atom is this one 1. So total number of sigma bonds 3 sigma bonds. And pi bonds, this one above and 1 below, so 2 pi bonds are there. And whenever we see such compounds where carbon is having triple bond, so then that carbon is in sp hybridized state and the shape of the molecule will be linear and this angle is 180 degree. So we can understand this with the help of few examples. So this is the first question. Okay, these molecules are given here and we have to find out the number of sigma and pi bonds in these molecules. So first is this example A. So for this we can write it in a expanded form. So I have written like this, these two carbon, this hydrogen I have written like this bond, and then this bond between both these carbon atoms, single bond, this carbon with the 1 hydrogen, this double bond here, this carbon 1 hydrogen, this I have shown like this, this bond between these two carbons, CH3, 1, 2, 3. So in this way, expanded form we can write, and then we can start counting first the number of sigma CC bonds between two carbon atoms. So first we can see here, this is a triple bond. So just now we have discussed, in case of triple bond, only this middle one is the sigma bond. So one sigma bond here, and this is a single bond. This will be the sigma bond only. And this carbon double bond, in this one sigma and one pi. So this is one sigma, and here this and this, between this and this carbon, one sigma. So number of sigma between two carbon atom is here 1, 2, 3, 4. So this is 4. Number of sigma CH. So all the bonds between carbon and hydrogen are sigma bonds. So this is 1 sigma, 1 sigma, 1 sigma, 2, 3, 4, 5, 6. So sigma CH is equals to 6. So we can calculate the total number of sigma bonds. 4 plus 6 is equals to 10. Now we can come to the sigma. After sigma, we will come to the pi C double bond C. Okay. So pi bonds between the two carbon atoms. So here we can see, okay, this is a triple bond between these two carbon atoms. So among these, in this triple bond, only the upper one and the lower one, these two are the pi bonds. Okay, and here in this double bond, these two carbon are having double bond. So only this one will be the sigma and one will be the pi bond. So we can say, okay, in the triple bond, in this triple bond, there are two pi bonds. So in this triple bond, pi bonds are 2, and in this double bond, there is the 1 pi bond. So total is the 3 pi bonds. So in this way we can do. So next example, again this is the next example. We can write it again in the expanded form. So I have written here. So first we can count the number of sigma CC bond. So this is the double bond between two carbons. So among this, in this double bond, one will be the sigma. Again double bond between two carbon atoms, one will be the sigma. Single bond between two carbon atoms, this will be sigma only. So sigma CC bond is equals to 1, 2, 3. 3. Number of sigma CH bonds. So we know all the bonds between carbon and hydrogen are sigma bonds. So this is 1, 2, 3, 4, 5, 6. So it is having 6 sigma CH bonds. Now sigma, after sigma, pi carbon to carbon bond. So this is a double bond. We know very well, in this double bond, one will be the pi bond. Here also same, one will be the pi bond. So only 1, 2 pi C double bond C are there. So this is the 2. So and here total number of sigma bonds will be 3 plus 6 is equals to 9. So now we can come to the next question, which is, what is the type of hybridization of each carbon in the following compounds? So we can see here, like this is CH3Cl. So we know very well here in this CH3Cl, all are the single bonds. There is no double bond. So where all are the single bond, in that case carbon is sp3 hybridized. So we can write this. This is sp3 hybridized. So next example, CH3 twice CO. So first we can write in this way. Yeah. So here we can see this CO is the ketonic group in the center, and on the left side one CH3, right side also one CH3. So now we can see how many bonds the carbon is having. So in this case CH3, all are the single bonds. For this CH3, all are the single bond, and in this case this carbon will be sp3 hybridized. Same with this CH3, because here also all are the single bonds. This carbon is having only the single bond. So this will also be sp3. But for this middle one, this carbon, ketonic carbon, this is having one double bond. And in such case, this carbon will be sp3, this will be sp2 hybridized. So again I will repeat. So first we will write this in this form. Now central mein this ketonic group CO will come. One side, because here it is CH3 twice, left side one CH3 group, right side one CH3 group. So for this carbon, it is having only the single bonds. So this will be sp3 hybridized. Same with this CH3 group, this carbon will also be sp3 hybridized, but this middle one, because this is having one double bond, so this will be sp2 hybridized. Okay. So next example is CH3CN. So we can write it like this: C triple bond N, and here CH3. So here we can see CH3, all are the single bonds, means this carbon is sp3 hybridized. But in this case, C triple bond N. So just now I have discussed that in such cases where triple bond is there, then that carbon is always sp hybridized. So this will be sp hybridized. The next example is HCONH2. First we will write it like this. Center में this C double bond O, NH2, and this side H. So again here this is a double bond. So this carbon, when it is having the double bond, so this will be sp2 hybridized. Okay. So this is the next example. So I have written it like this. So here C triple bond N. So one by one we can see the carbon hybridization state. So this carbon, all are the single bond. So this will be sp3. This carbon, one double bond is there with this carbon also and with this carbon also. And in such case, carbon is sp2 hybridized. So this will be sp2, this will also be sp2. This carbon, triple bond is there, and in such cases, carbon is in sp hybridized state. So this is sp hybridized. Okay, hope this is clear. So moving on to the next example, here we have to tell the shape of the following organic compounds. So first example is H2C double bond O shape. So first for this type of questions, first we have to see the hybridization state of the carbon atom. So because here we see double bond O, C double bond O. So for this carbon, it is in the sp2 hybridized state, and in such cases it is trigonal planar. Shape of this molecule will be trigonal planar. Next example is CH3F. Here all are the single bonds, so it is in, this carbon is in sp3 hybridized state, and in sp3 hybridization state it is the tetrahedral. Shape is tetrahedral. HCN, C triple bond N. So this is sp hybridized, and in such case shape is linear. So I hope by these simple examples it is very much clear to all of us about all these hybridization state of carbon, sigma and pi bonds, and the shape of the organic molecules. So thank you so much for watching this video. So if you want to study all the topics of general organic chemistry, please download my app, and the link will be shared in the description box. So thank you so much.